Okay, my watch says 18Z, so let's get started. My name's Scott Lindstrom, and I'd like to welcome you to the FDTD Satellite Applications webinar for today. We're very happy today to have Linda Gilbert, lead forecaster from Marquette. Her title today is Utilizing GLM Products for Marginally Severe Events. Next slide, please. This is part of an ongoing series of webinars. Used to be Satellite Chat, now it's FTDD Satellite Applications webinars. As I said, I'm Scott Lindstrom. Dan Bykos at Sierra and I help coordinate this. We're always looking for speakers, so if you want to volunteer someone or volunteer yourself, please just send us an email. Next slide, please. Just some protocol. We'll have about 20 minutes for Linda, then questions and answers. Send those via GoToChat. We hope to be done by 18:30 UTC. Don't press hold. Mute when you're not speaking. Take it away, Linda. Thank you.
All right, great. Thank you so much for that great introduction. So, I guess I'll just jump right into it. All right, so first and foremost, just a quick disclaimer. First, I'm not a quote unquote doctor of lightning, nor do I play one on TV. You can just consider me an enthusiast. And this is really something that has stuck with me over the years since early on in my career. Lightning has always been of a big interest to me. And also just wanted to make mention for those of you that may or may not have seen a version of this presentation last year, it is a revisit of that presentation. There was one given through the Tower S program and the GLM science meeting. So this is kind of a little bit of a mishmash of both of those presentations that were provided last year. All right, I want to give you all the conclusions up front. So first of all, some of the things that we've talked about here locally in our office, and some of the things that have come up over the years in terms of what's important, specifically when we're talking about really any convective event, but particularly when it comes to even marginal events. Having somebody perform a mesoanalysis leading into any sort of convective event is really highly recommended. It helps to maintain situational awareness. And even some of those high-end days, you know, that's the first and foremost thing that everybody thinks about. But those marginal events, I think, is also very critical for having someone in that mesoanalysis position. Ideally, that should not be the radar operator, especially I know that that can be a little bit tight from a staffing perspective for those of you in the Weather Service. But really, it shouldn't be somebody who is in the radar operator seat. And that's just to be able to maintain better situational awareness for both individuals. But communication between the mesoanalyst and the radar operator is absolutely essential, and that cannot be stated enough there. All right, and when it comes to really any sort of mesoanalysis, whether you're doing it in an official capacity or otherwise, you know, other just things that have come up over the years, use all available tools and resources at your disposal, including satellite, right? And that's why we're here talking today. But also checklists can be very helpful. And I'm not going to really spend any time on those checklists, but there is one that I will reference here throughout this presentation. And you can always chat me up or send me an email after this presentation if you're interested in diving a little bit deeper into that checklist discussion. And then really, why are we here today? Well, lightning data does and can help. And of course, there will always be caveats, you know, especially when it comes to these marginal events in particular, but there is a benefit to looking at lightning data and incorporating that in your mesoanalysis. And I think it's also important to develop your own local thresholds and methodologies. This is coming from an Upper Michigan perspective. And, you know, this may or may not be applicable for wherever you're at within, you know, the country. But there are definitely some things that can be taken away, I think, across the board. But again, it's important to just take a look at what works best for your area locally. And lastly, on the conclusions up front, this is something that I'll talk about again at the very end, but it would be really nice to have more readily and easily available GLM data. It would be great for revisiting events. There's a lot of information to digest and unpack, and even though GLM has been with us for a few years now at this point, there's still so much that we're learning on a regular basis with GLM. So yeah, it would be great for something like that to come to fruition. So an earlier version of this presentation included graphics from a local meteorologist here, Ryan Connolly, and some of those images have been replaced, if you will, by Scott Lidstrom and Dan Bykos. So thank you very much to you both for providing some of those images that you'll see here in this presentation. So the mesoanalysis process, we've incorporated a modified near storm environment checklist from WFO Grand Forks. So special thanks to them from our Sue for providing that. And you'll see that checklist here. And I just also wanted to make mention that we've locally incorporated a hail checklist from my former office, WFO Pleasant Hill, which is serving the Kansas City area. And most of our events here locally in Upper Michigan fall into the Donovan method category for those that are familiar with that process. And again, you can reach out to me separately if you're interested to have more discussion on that. Two other things I want to make mention here of what we've done locally here. So last year I presented an all things lightning presentation to the staff, and that was to kick off the 2020 convective season. And that was received pretty well from the local staff. And then what we did this year was something a little bit different. I'd come up with and developed a joint mesoanalysis exercise with our neighboring office, Duluth, because we share a lot of overlaps when it comes to some of the challenges from a forecasting and warning decision process perspective that crosses our boundaries. And so I worked very closely with not only my local Sioux, but the Duluth Sioux. We worked together, put on a joint exercise between our two offices, and received some pretty positive feedback from the participants. And again, you can chat with me separately outside of this presentation if you'd like more information on that. But these are just some key things I think that could help set folks up for success when it comes to the convective seasons. All right, diving right into it. The local event that started it all was actually April 7th of 2020. This served as an inspirational event for determining if and how GLM could be incorporated into the process, the mesoanalysis process for future events. So some of the questions that came up as a result of this inspirational moment, as I call it, the first one being higher end events tend to get a lot of focus, but what about marginal events? Again, that's very important to us here in the Upper Michigan area, as I'm sure it is to a lot of folks. There's a lot of attention paid to some of those higher end events, but what about these marginal events? And can the warning decision process be enhanced for these marginal events by incorporating GLM into the mesoanalysis process, which is why I touch on that here in the beginning of this presentation, and why you'll see a few sprinkles of mesoanalysis here in this presentation. So utilizing one of these checklists, again from WFO Grand Forks, that we've locally modified here for that April 7th event, this is what we identified here leading into the event in terms of instability and shear parameters. It turned out that there was only one LSR for this particular event, and here you can actually see early on in the event that there was some signals of increased lightning activity about 9 minutes before the LSR was issued. And I'm just kind of going through this fairly quickly, but you can see an overall trend that there is lightning in the lower part of the peninsula here that also juts into Lake Michigan and Green Bay's area. You can see pretty persistent activity. And I'm just going to go back here for a couple of frames here. But there in the lower part of the peninsula here, you can see again that some of that lightning activity right around this time step here really started to ramp up just ahead of that LSR being issued. So that was really encouraging as an early event. And you can see here the entire lightning event on loop here. I'll let that play out here for just a second here. So again, this was kind of that spark to get things going and think about, okay, well, what can we do from a GLM perspective? Is this going to be helpful for our warning process? All right, so the next event that I identified here was June 2nd. And I did want to mention that there were actually a lot more events, about 12 events or so over the course of the year 2020 that happened. And unfortunately, I haven't had a chance to dig too deep into 2021, but there's a few events that kind of stand out for 2021 too that I'm excited to hopefully have a chance to go back and revisit. But for June 2nd of 2020, here's what it looks like. So pretty marginal, right? Nothing stands out saying this is going to be a high-end event. And sure enough, there were only 3 LSRs issued. One was severe. But what's noticeable from this perspective, just to kind of give it away here, is that about an hour before the first LSR was issued, there was actually lightning started to pick up. And then it was a notable uptick, again, about that 10-minute period before the severe LSR was issued. So here's a picture of some hail that happened in the local area. This is courtesy of our Opal, and this happened in his local area. And I did want to do just a quick view here of the Vizsla Total Lightning product, and you can see there's that lightning that's starting to creep upwards, and then it's overspreading across this area of interest. Moving right along there, you can see quite a bit of lightning activity really starts to cluster together. And you'll be able to see this play out with GLM as well. And quite a bit of lightning activity, especially once it got over Lake Superior. So that was pretty interesting to look at as well. So here's the total optical energy product between about 9 and 12 Z that morning. You can see the sun rising with the visible satellite imagery there. You can see that lightning activity really picking up. And again, once I went back and revisited it, there was a pretty noticeable uptick about 10 minutes before that severe LSR was issued. And here's the FED, or flash extent density product, for that same time period. And moving on to the July 18th, 19th time period, this one is a little bit more of a higher end event for our area, so I wouldn't necessarily classify this as marginal, but I still thought it was very interesting to take a look at here. So here's the area, average flash area product, AFA, total optical energy. Now, in this particular event, we ended up getting a number of severe events. This was mostly a wind event. But the gist of it here is, you know, it's a little bit of a higher end event for our area here. So as this convective complex was coming on shore here off of Lake Superior, it was hitting with 60, 70 plus mile per hour winds. And then it kind of died off as it continued its eastward trek. So just quickly wanted to go through here. It's pretty persistent in terms of the activity. You know, you can certainly point out some points in time in which some of the activity was really spiking, indicating that perhaps there was a individual cell or cluster of cells that was, you know, going to be producing something. But, you know, again, from a marginal perspective, this is just one of those events that, you know, was outside of that marginal boundary, but I still thought it was very interesting to take a look at and hear in terms of some of the lightning activity. All right, and then this is just from the Green Bay radar. Our radar was actually down for this event, which is why I'm utilizing our neighboring offices for looking at radar here. Okay, so moving on to the next event here that was definitely more into that marginal category, August 26th. So you can see here that we had several warnings out. This was actually a little bit more of a heavy rain type situation. So you can see some of those icons there from LSRs. But the two that I wanted to focus on was the hail and the lightning LSR. So here's the energy density product at the 8Z hour. So this is in the overnight period. And this actually is what ended up triggering a barn fire, and I don't know if you can see my mouse, but essentially where you see that cluster of lightning activity is where an LSR was issued for lightning causing a fire in that area, and that's down in the central part of the UP. And here's that flash count density product. You can see lots of lightning activity is pretty much the gist of what I wanted to show here. Okay, so There was nickel size hail that was that we received a report for, so that was LSR'd. And again, going back to about that 10-minute time period before that LSR was issued, we again noticed an uptick in lightning activity. In terms of the start for lightning, that was about 40 minutes ahead of when that LSR was issued. So we saw that lightning activity starting to pick up in the eastern part of the UP. And then within 10 minutes prior to that LSR being issued, which was nickel size hail, so not technically severe at this point anymore, but you know, again, that 10 minutes is giving us a heads up that, okay, this storm really strengthened and ended up putting near severe hail down. And then the flash count density product just as another visualization here for that lightning activity. And again, we're focusing on the eastern part of the UP here. Okay, and then the next case that I thought was very fascinating was August 31st of 2020. This was a low-top supercell that ended up producing a brief tornado, an EF1 with 95-mile-per-hour winds is what it was rated at. So less than a mile for the path length. The width was pretty short there, and the duration was only about 2 minutes or so. It was observed, and then of course, did get some property damage as a result of this. And then it ended up collapsing and creating a downburst event afterwards, and ended up doing some more damage. Initially, there did not seem to be any sort of lightning activity associated with the storm, but I was like, I really want to go back and take a look here. Was there something that popped up? And it's very difficult to see on this particular product, but it turns out that there was. You can see it a little bit better here in the flash count density product, a little tiny blip there. And what we're focusing at is the south central part of the Upper Peninsula of Michigan. And stepping through it here, you can see the average flash area. And sure enough, there was a blip of lightning about 11 minutes ahead of when that LSR was issued. So I thought that was very, very interesting. And here's the total optical area product. This is a loop here. Just little blips here and there, and it's a little fast, but you can see just a little bit of a blip there. And I'll move here, and there it is. So this occurred, again, about 11 minutes before the LSR was issued. So very, very interesting indeed in terms of some potential lead times when it comes to GLM data. Okay, so moving forward, all of this is just the beginning and really just barely grazes the surface. I feel like there's still so much, as I talked about at the beginning of this presentation, to incorporate, look at, analyze, dig deep into GLM stuff. So some identified goals that is more of a longer term type goal is of severe and or marginal events to include GLM data, and then continuing to identify that we can utilize and incorporate GLM analysis process. And then in terms of a quantifiable measurements, what can be applied quantifiably when assessing storm growth? So is there an opportunity to look at specific rates of increase, for example? And I touched on this at the beginning, but really the dream is the creation and emergence of some sort of GR equivalent tool for satellite imagery. We've got something for radar, and that's great, but man, if we could have something for satellite imagery, that would be great. That's one of the big challenges that I've come across with respect to trying to go back and analyze events using GLM data, and really any satellite imagery for that matter, but really GLM in particular has been a bit of a challenge. And I've got some workarounds and I've been able to use them, but it would be so much easier if we had something equivalent to GR, for example. And just to kind of wrap this up, first, thank you so much. And second, this is a picture here from the first introduction, if you will, that I had to the effects of lightning. And we were going out on a storm survey. This is from Winter Park, Florida, my first office, Melbourne, Florida, and went out on a storm survey with the folks there at the time. And we stopped by to look at this lightning damage. So, you know, whatever we can do to help warn folks, give folks a much better heads up in terms of not just lightning, but incorporating lightning data into other severe events, anything that we can do to help increase the warning decision process, the lead times for that, I think is key. So that's all I've got. Thank you all so much.
Thanks, Linda. I'm going to take a prerogative and ask a question right away. For the, I wrote it down. For the 26th of August case, I think you had some LSRs with flooding, and I'm just wondering if you have, or excessive rainfall, and I'm wondering if you've used GLM as an indicator of excessive rainfall. It looked like in that particular case, it looked like there was really nice training with the lightning.
Right. And the answer is no, but I think that you're definitely right that there's, I think there's a potential there to look a little bit deeper into that. But for these purposes, that was not something that I'd focused on for this particular set of data.
And I'm also kind of curious, for making one of these kind of case studies for the office, I'm wondering what the time constraint, I mean, how long does this take you? And, with your other responsibilities on the forecast desk, I'm just curious about the time constraints when you're creating this kind of thing.
Sure, there is definitely, it's not something that is, very easy to just knock out. And some of that is because of the challenges of, especially if you don't capture the GLM data in the moment. But now that I've, become more familiar with, like, you folks, for example, having access to this data, the limitation has historically been being able to recreate the GLM imagery. Again, kind of going back to that, it's really easy to pull up raw radar data, throw that into something like GR, and boom, you can go back and revisit a case. But it's been much more challenging from a GLM perspective to be able to rebuild that raw data and work with that raw data. So having it be in a visual, from the gridded perspective, as opposed to that raw point data that we aren't using operationally right now, that's been the biggest challenge, is being able to go back and rebuild that stuff.
Okay, thanks. I have no other questions, and I'm looking at the question boxes, and at present, I don't see anything indicated. I can allow people to unmute themselves, I think. Well, maybe I should ask Dan Bykos to do that because he's more familiar with GoTo. But if you have a question, you can always raise your hand. I'll have to look at the attendees, and we can figure out how to unmute you. But otherwise, let's see, oops, there we go. I don't see any hands raised, and I don't see any questions asked at the moment. We'll give it just a little bit more time, and maybe we can give people 5 extra minutes back on their day. And I want to thank you, Linda, again, for a really interesting view of how GLM is used in the forecast office for, I don't want to say run-of-the-mill, but for events where you might not be in a high risk or a moderate risk, or you're just in some kind of risk, and GLM can help you. GLM can be one of the tools that you're using to help assess what's happening.
Right, absolutely, and it's been awesome to be able to see something like this that can be helpful, because when it comes to higher end events, I don't want to say that it's easy, because it's not. I know what that's like, but I think that in some respects, when it comes to marginal events, do I, don't I warn? I propose the idea, the concept that it's sometimes a lot more challenging. And so that was kind of the basis of going back and revisiting some of this, is how can we, potentially increase confidence when it comes to do I, don't I warn for these marginal events.
Right.
This is Dan from Sierra. I'll ask a question. Linda, have you looked at time series plots for time trends, like, for example, from Prob Severe, or maybe the tracking mediogram tool from AWIPS?
Right. Again, not for this particular focus here, but working from both an operational perspective and then some of the experience that I've had through the HWT, for example. There's definitely some value for sure in those areas and those products, but that wasn't the focus for this particular revisit.
Okay, last call for questions. Well, hearing and seeing none, I'm going to thank Linda again. A recording of this will be made available, so if you have people in your forecast office who were unable to be here because of shift work or for other reasons, and you want them to view this, by the end of the day, there will be a link. And if you go to the Satellite Chat website, which we showed at the beginning, you'll be able to find this. So thank you again, Linda. And everybody else, have a great day.
Thank you all again.